Rock salt is the raw material used to make chips. First, it is ground into powder and put into a high-temperature furnace for purification. It is purified to 99.99% purity. Then it is cut into 300 mm diameter slices. The thickness is 0.75 mm. There is a production line on the back. A small opening is opened to let the equipment identify its direction. The crystal ball is very fragile. It is easy to break when it is touched. The cost of a crystal ball is about $100. But after it is made into a CPU, its value can reach $100,000. It is 10 times more expensive than gold. The crystal ball chip from the fluid line cannot be guaranteed to be perfect. It also needs to be tested strictly for each crystal. The chip with defects is often only a difference in performance. So the test program will mark the crystal with defects. Then it is classified according to the grain rate of each crystal. Intel is using this method to distinguish i9, i7, i5, and i3 processors, and the damage points inside the processor will decrease as the price goes down. This is the CPU of a Taiwanese computer. The chip we often talk about is the integrated circuit inside the chip. It has 24 computing cores, a memory controller, and a GPU graphics chip. After the core is enlarged, there is a division of different functions inside. If we enlarge one of the divisions, we can see the layout of 44,000 crystal tubes. So many crystal tubes only account for 0.17% of the total number of crystal tubes. If we enlarge the chip to 100,000 times, we can see a dense metal guide layer. The bottom of the guide is the crystal tube responsible for the basic logic operation. The top of the crystal tube is full of insulating material and metal lines. A chip has several hundred kilometers of lines. There are 5 layers of metal guides on each side of the crystal tube, which are connected by metal holes. A CPU chip is built on top of each other in this form. The material used to make the chip is a 300 mm diameter silicon core. This silicon core can make 230 CPU chips. It is much smaller than a memory chip. A silicon core like this can make more than 900 memory chips. Before production, 25 silicon cores are taken out and piled up into a stack. Then put them in a box with a transmitter. These boxes are transported to each device through the top track. The system sends the box to the corresponding device according to the specific steps. The device has a dedicated machine arm. It will process the disk on the workbench according to the system's instructions. After unloading the goods, the box continues to enter the track and rushes to the next device. There are thousands of such boxes in the entire manufacturing process. The silicon core is the first step in chip manufacturing. After applying the silicon core, it is placed on a baking tray. The temperature of the baking tray evaporates the impurities on the glue. Then it is sent to the workbench of the chip. The top of the workbench is the ultraviolet light and a film with a pattern. The pattern of the light passing through the film is projected onto the transmitter through a transparent focus. Then the transmitter is placed in a hidden container. It will remove the ultraviolet light. What is left is the circuit diagram on the film. The carving of the circuit diagram is done on the chip. The laser is the most important tool in chip manufacturing. The bottom is a UV light source lens. The top is a set of lenses for focusing the light. There is a film with a circuit diagram on the top. It is equivalent to the bottom of the washing photo. At the bottom is the trapezoidal frame of the carving circuit disc. The light travels through multiple refraction to the film. After more refraction, the pattern is focused to 1/4 of the size and projected onto the laser. This process includes 2 most important steps, laser and time. The film is a 6-inch square, can fit 2 CPU circuits. The laser is equivalent to copying and pasting the pattern onto the disc. It can write hundreds of thousands of circuits 230 times in a few minutes. Each layer of the chip has a different circuit diagram. A 80-layer CPU chip requires 80 different patterns of film. Each film costs $300,000. In order to improve the efficiency of production, the chip manufacturer will operate at least 400 devices at the same time. Usually, 50,000 films can be produced every month, or more than 10 million chips can be produced. But even so, it is still not enough.